Hi Precalc, I'm back. My SD card died during that, so as with filmmaking, we have to just go back to the start. It's all good. So section 1.4 and 1.5, I'm going to do them together as one lecture. And for the homework, you're going to submit them together as well. So the 1.4, 1.5 homework, I want you to submit that homework together under one file, one icon. So I'm going to talk about some definitions, and I don't put definitions on the exam, but you should know what these words mean so that you understand questions and that you answer them appropriately. So when we talk about the word domain, what we're talking about is a set of inputs that go into a function or relation. And some students tend to think of that as the X values. The X values go in. And then therefore the range, that's going to refer to our set of outputs. So some students refer to that as the Y's. The values that come out of a function. So domain is what goes in, range is what comes out. Okay, so when we start to talk about how you can combine the domain and range, the relation, we can talk about how you, I have to watch how I say this. We're going to now talk about how you can combine a domain and a range. If you combine a domain and a range with no rules applied, we would call that a relation, okay? There's no pattern to how the domain and range are paired. Okay, so there's no particular patterns, there's no rules to break, there's just nothing. A relation means that they're just paired just in a random fashion. Now, a function is a level up from a relation. So if you think of this as like relation is the floor 1, function would be the second floor. So if relation's the first floor, the function would be like the second floor. This is now higher on the hierarchy. This is, I love my language this morning. This is higher up. So a function has a rule to it. So each x goes to exactly 1 y. That's a rule. You'll notice, if you've never had me before as your professor, that I will laugh at myself. You sort of have to laugh at yourself in life. So we're all just trying to get through it. Okay, so the idea is a function is each x goes to exactly 1 y. That's a rule. And you have to satisfy that rule for the equation to classify as a function. It has to satisfy this rule. Okay? Whereas a relation, which is on the first floor, doesn't have to satisfy any rules. But this one does. So this means that each item in the domain goes to exactly 1 item in the range. When I'm talking about x and y, I'm referring to the inputs and outputs. So each item in the domain goes to exactly 1 item in the range. There is another level above this. Maybe some of you know it. Maybe some of you know level 3. Okay, I'm not going to touch on level 3 till we get there because there's already so much that I have to get through. All right, so let's play a little game. Is this a function, yes or no? And I'll just hold the camera over each of these for a moment. Just think, is that a function, yes or no? There's the first one. Here's the second one. Here's the third one. Okay, so what do you think? Could we classify this as a function? Hopefully you said yes, because each x goes to exactly 1 y. Each x goes to exactly 1 y. If you're already ahead of me, you know that this is actually even a fancier pattern than a function, but I haven't, like I said, I haven't gotten to that yet. in the course. Okay, how about this? Would this be a function? Is each x, right? You're thinking of this column as like the x's, this column is the y's. Is each x going to exactly 1y? Would we say this is a function? And hopefully you said yes, this actually is a function because each x is going to exactly 1y. If we think about it in terms of ice cream, A goes into the ice cream store and gets chocolate. B goes into the ice cream store and gets strawberry. C goes into the ice cream store and gets strawberry. So B and C happen to like the same flavor, but they each just only got one item. So that's a function. We know that they're only going to go to one item. Now, how about here? Is this a function? Right? This is not a function, okay? A isn't breaking any rules. A goes into the ice cream store and just gets the chocolate, but B walks into the ice cream store, right? And they're going to get strawberry and mint, right? You can't have two flavors, right? A function can't have two different outcomes. So this is what's breaking this one. We could not classify this schematic as a function because this x value is not allowed to have two y values, right? The definition is you have to go to exactly one y. You can't go to 2 or 3 or 4 or 5. It's, you know, you just get, when you go in the ice cream store, you're just going to get one flavor, okay? All right, let me see. So we just looked at whether a schematic is a function or not. Let's also look at whether a graph is a function or not. And what technique do you use to tell if a graph is a function or not? Do you know the tests that you would use? To tell if a graph is a function, it must pass the what? Okay, the vertical line test, right? VLT, vertical line tests. So to do the vertical line test, you draw in your mind like a bunch of vertical lines, and it's only allowed to pass through the graph once. If it touches more than once, it's not a function. So like if I look at this and I draw in my mind like a lot of vertical lines, they only touch the graph once, which means that each x only goes to one height. Each x only goes to one height. That's what that means, okay? Each x only goes to one height. So this guy over here would classify as a function. Right, this guy's a function because as I draw these vertical lines, it only touches once. But now what happens when I do this one? Right, this is touching more than once, right? For one x value, it's going to two different y's. At least not on the end here, but over here it is. Right, so if I just make up something, if I just make up a point, hold on, let me get rid of that. So if I just make up a point, this could be the point like 3, 5, and this could be the point like 3, -2, right? 3, 5, and like I'm just making, this is just random. So 3 is going to 5 and 3 is going to -2. It's like that kind of idea. 3 is going to a height of 5 and 3 is going to a height of -2. You can't go into the ice cream store, right, and get two different flavors. It's the same idea, but we're just doing it graphically, right? One x value can't have two different heights associated with it. So that's what the vertical line test helps you figure out. Okay, let me see where we're at. All right, maybe this video I'll go up to here. All right, I'm going to put this topic on your test, so please make sure you're good with this. Find the domain and range of a graph. So when you talk about a domain of a graph, again, that refers to your x values. Your x values on a graph are horizontal. Your y values on the graph are vertical. So when I'm asking you what x values are you using, you have to actually span your graph horizontally. So to draw this little picture here, I had to use all the x values. I might have to pull this over a tiny bit. Such is life. Okay, so I had to use all the x values to draw this graph in between -2 and 3. Okay, so I had to use all the x values between -2 and 3. You can write it in inequality notation, or if you like interval notation, you're certainly welcome to write it like that. Okay, so for me to draw this picture, the x values, you have to scan it horizontally. The range is the y values. The y values go up and down. So you have to figure out what up, down, y values. So the lowest point to this picture is a -1. The highest point to this picture is a 5. So for me to, it vertically spans from a height of -1 to a height of 5. And again, if you like that really nice interval notation, that's how you'd write that. So again, domain, you're scanning your picture left to right, range, you're scanning your picture bottom to top. What's the lowest? Because I didn't use all the heights. I didn't use any heights down here. I didn't use any heights up here. I also didn't use all the x's. I didn't use any x's here. I didn't use any x's over here, okay? So you're just using a specific set of x's and a specific set of y's to draw the picture. And the question's asking you, okay, what were those values? And the reason why we have the inequality or the interval is because you're using everything in between those values as well. All right, let's play that game again. Oh, okay, I didn't finish the first one. I could almost hear you guys saying that. Oh, she didn't finish. Is this a function? Does it pass the vertical line test? The answer is yes, it does. So why is it a function? Well, it's a function because each x goes to exactly 1y. That's what makes a function. Each x goes to exactly 1y. Everybody's going in and getting one scoop of ice cream, one flavor. All right, let's do the next one. What do you think the domain of this guy is? This guy has arrows, so think of it like a movie. Think of it as like this guy's going to keep going up and over. This guy's going to keep going down and over. Okay, think of it like a movie when it has arrows. All right, hopefully you said the whole number line, right? It's going to go from -infinity to infinity. It's going to go all the way to the left. It's going to go all the way to the right, and it's not going to stop. So we're going to say -infinity to infinity. If you prefer other notation, you can say all real numbers, or in words is fine. The range is the y. So it's not only is it going over, it's going all the way up. Not only is it going to the left, it's going all the way down. So range is also going to cover the entire spectrum. It's not going to stop going up. It's not going to stop going down. Okay, would we say this is a function? Does it pass the vertical line test? Hopefully you said yes. And again, it's because each x goes to exactly 1y. All right, let's try one more of these and then I'm going to can it. That's the end of this video. Let's look at this guy. What do you think the domain of this guy is? This guy is half open and half closed, so be careful. He's like a combo of this and this. What would you say the x's are on this? So as we come over from the left, where does this guy start? Okay, this guy starts at 4. It starts using x values at 4. And it doesn't stop because it's got the arrow, so it's going to keep going over. For those of you who like interval notation better, that would be written like this. X is greater than 4 and it doesn't stop. I'm not picky on notation. As long as you have the right answer, I'm happy. You use interval or inequality notation, I don't care. All right, range. So range is from bottom to top. So come underneath it. Where do you start using a y value? Oh, you start using a height at 1. This is a height of 1. And it doesn't stop going up as it goes over. So it starts at a height of 1 and it goes to infinity. If you like inequality notation, that means that y has to be greater than 1. Now, would you say this is a function? Would this guy be a function? Does it pass the vertical line test? Hopefully you said yes, it is. And again, because each x goes to exactly 1y. Okay, gang. We're going to do more videos on 1415, but that's a wrap on this guy. Catch you again soon. Bye-bye.